Okay, so here's a video showing how I kind of drew up this quote-unquote fixture, which is really just a registration line. Kind of went out of my way to make something just to show you kind of how you can work with different coordinate systems, place your part onto a fixture, and create multiple files, one for your jig and one for your part. It seems to be the most helpful thing for the tutorial purposes. So here I'm just kind of pocketing something out with some little mouse ears in the corner that are larger than my end mill diameter, so I can get in there easily with that big 5/16 end mill. This is a little out of order if you've watched the first few videos because we already cut this. This video focuses just a little bit more on the computer side of things. So you can see I'm putting a coordinate system in the bottom left-hand corner, and that corresponds to that MDF. But the important thing here is that that pocket gives me another lower left-hand corner to register my piece on, and a very flat plane for my Corian to sit on. So I can keep that coordinate system from the top of the MDF, but when I put my piece into that little pocket, assuming I've measured the thickness of my piece correctly and the length and width, I'm going to be able to very accurately locate onto the stock. And this is helpful if you have like stock that's very, very close to your final dimensions, or maybe you're modifying an existing piece, that kind of thing. So I'll go into more detail about like these tool paths and how to generate them. This is just kind of like the quick start guide, so we'll get into the weeds maybe later. That's why I've sped it up so much here. But you can see I'm post-processing there, and you can freeze frame if you need to. In inches to Linux CNC as the post-processor. And it creates this G code, and I just post that out onto a thumb drive and bring it over to the CNC computer. Probably don't need to worry too much about the nitty-gritty of the G code either, maybe even ever. Hopefully you don't have to. The file extension doesn't really seem to matter. You can open anything. I think there's a few standard ones here, and some of them open automatically in Linux CNC, but you can open by all file formats or something. So now we're back over in the real world, and I've loaded that G code in so you can see the tool paths there. And again, I'm taking the feeds and the rapid override way, way, way low. I think here what I'm doing, I'm doing a G0, X0, Y0 in the MDI tab, which just, with the rapids down, is just going to jog that over to my 0, 0 position in X and Y only. Make sure you don't do a G0, X0, Y0, Z0, or you might crash. But again, another sanity check. You really have to do these sanity checks unless you've run a part a million times to make sure all your zeros are correct. In this case, my X and Y 0 again are on the bottom left of the MDF. I don't really need to worry about where my stock is there because I've modeled that all in 3D relatively accurately. It's mating on that top surface of the pocket, which is pretty accurate because I milled it with the same end mill that I'm going to mill my part. Hopefully all that makes sense. You don't really need to, yeah. I think here I'm just verifying Z again. One more reminder that you want to check the tool offset as well as your work offset to make sure that you have a good 0. So it looks like I'm showing the 3D model again. That's the final model, and the coordinate system is the same for the cam that I used to mill the final model. I guess that's what I was showing. And I'm going into the first cuts here. Just really slow. Again, keep the rapid way down and the feed way down. You can keep the feed all the way to 0, so when it's finished plunging down to the point where it starts, it doesn't even move. And then you can just creep up the feed, make sure everything's in the right spot. And if you post things that you can put, there's no harm in most materials posting things out at like half the speed they're supposed to be, and then doing a feed override up to like 200%. Yeah, just give yourself enough room so you can get as high or as low as you need to be. But it's a good way to figure out the correct feed and speed for a material. If you're looking online in cookbooks or something that some crazy machinist in the dark corners of the web said was correct, you're just taking someone's word for it, and your material might be different, or temperature, who knows. So just listen to how the machine sounds, and you'll be much better off, and creep up on the final feeds and speeds. If you're going to be doing a production part or something, you're going to want things as fast as you can get them, but just start slow. There's really Alright, this last little bit, right now I'm at 1 time speed. I think this is like about an eighth of an inch step over and like a quarter of an inch depth cut at like 50 inches per minute. So pretty conservative, but just to give you kind of like a sense of the speed of the machine. You could refer back to that if you're wondering what 50 inches per minute looks like if you haven't done this stuff before. And then in some of the next videos, I speed it up quite a bit, and you can just watch. It's not particularly informational. This piece is just some nonsense that I put together to make sure that the machine was working well and kind of demonstrate what I can do. And maybe we'll go in the next video over how to make those tool paths specifically in either Fusion 360 or SolidWorks or both, maybe even RhinoCam, for people that are doing it. I had one more thing to say before I shut up and just let you watch the rest of this thing machine, which is that if you're wondering where to start with feeds and speeds, you can hardly go wrong at 60 inches per minute, and maybe even up to 100 inches per minute, but maybe start with 60. I actually don't have much experience with this machine yet, so I'm not sure what it can pull off. As far as width of cut, 1/3 diameter or less is great. These high-speed or so-called high-speed tool paths that are generated by like modern CAM software like Fusion 360 are really optimized for a pretty narrow width of cut and much deeper depth of cut. So like machining steel on the big fancy new CNCs, you're going to have like maybe like a 32nd of an inch width of cut and maybe a full inch or 2 inches depth of cut. So you can keep that in mind. So 60 inches per minute, good place to start. 1/3 cutter diameter for width of cut, and depth of cut really depends on the material, constraining that how much material you're removing at a time. Maybe start at like a quarter of an inch and creep up to see if you're bogging the machine down. That's basically the limitation. And then the spindle speeds we don't have automated quite yet. I'm hoping to get to that next. But you can just don't put it so high that it sounds like it's going to fly apart or the bearings are having problems. That's it.